Hello, this is Unit 4, Topic 1, Introduction to Hypothesis Testing. So the goal of our entire semester, all of our Unit 1 information, as well as confidence intervals, our probability and distribution information, the goal of all this has been to get to hypothesis testing. So far in stats, we've broken it down into two different types of statistics. We had descriptive statistics and inferential statistics. Well, with descriptive statistics, we just describe data by finding a mean or a standard deviation, or we come up with a graph or two for the information. This is always going to be your first step, regardless of whether you're working on the project for the course, or if you are doing a very full-scale project where you eventually want to use inferential statistics. Regardless, you will still start with the descriptive statistics. However, the major goal is to make predictions, which is the reason why statistics exists. So remember, we originally have no information about the population, and by using statistics, we're able to answer questions pretty accurately about the population. So this is the whole reason why stats exists, and I call hypothesis testing the heart of statistics, and it's really the end goal of anything that you do in stats, any kind of project at all. Run a hypothesis test and then summarize everything from there. So there was three major components to inferential statistics. We mentioned these originally, and the ones that we looked at in Unit 3 were the point estimate. That was a single number that is a best guess for estimating a population parameter. So for estimating a population mean, we would want to use the sample mean. If we're estimating a population standard deviation, we'd want to use a sample standard deviation, and so on. Confidence intervals, however, were more realistic because they gave us a range of values. So instead of just having, a single number to estimate the parameter with, we're saying, hey, we do have variation that happens with our sample, and so we're going to accommodate for that by giving a range of values in order to estimate our population parameter. Finally, we have hypothesis testing. Hypothesis testing is going to be all of Unit 4 as well as Unit 5. So we're going to follow the same 7 steps for every single different hypothesis test that we get. So I find that students at first find there to be a lot of information that goes into hypothesis testing, but you have a lot of time to get really comfortable with it, and then just make small changes needed for each individual type of test that you do. So this first topic here has a lot of information, but it's almost all of the notes for the entire unit. So it's kind of a trade-off. I definitely recommend listening to this whole lecture, even if you have to pause and come back, because there aren't going to be very many, lecture-style topics for the rest of this unit. There will be some, and there'll be videos that go along with problems, but they're not going to be anything like this. This is almost all of our notes here. So again, hypothesis testing is where we actually answer a question, which is usually what you want to do when it comes to using statistics. So for example, the stats department, so myself along with some students, we are currently working with the study in order to help them estimate the number of people that are going to be coming into the city for the solar eclipse in 2017. So we're going to perform a survey, and we're going to actually do the sampling, and then we're going to answer that question of how many people are coming into the city. So we're going to estimate that a number of different ways, but the overall goal is to answer that question for the city. So the question claim that we're looking to answer, that's, how many people are coming into the city for the solar eclipse. That would be the claim. In general, hypothesis testing is a method that uses sample data to decide between two competing claims, which we will discuss as we look at some of our steps for hypothesis testing. There are 7 steps, like I said. We will follow them every time in the same order. So it's pretty similarly to how I do my confidence intervals, where I'll split the paper in half and then split one half in half. And it's going to be very similar to that every time. I'm going to take my piece of paper and organize it the same exact way. So the actual organization part of it is, I don't know, good, but there's a lot of pieces of information we need to get good at before we start feeling confident with hypothesis testing. Confidence intervals, however, will not go away. They're hand in hand with statistics. You always want to summarize your sample data, even if you are just going to answer a question. So we will be finding new confidence intervals and the old confidence intervals, but we're going to be using Stata primarily from here on out. So once you've completed the Unit 3 exam, that's kind of your initiation to finding your confidence intervals via technology only. Before we get into anything, our 7 steps, what I would like everyone to do is pause and just write down what each of these symbols are. So if you don't know all of them from point blank, I would put them on flashcards. You will need to know them. Pretty instant recall kind of knowledge. But you are going to have your note sheet and everything for the Unit 4 exam and the final exam. So you don't need to be, completely independent with these. But I would recommend having this information be instant recall. So pause and see how many you can fill in. So notice on the left, the top 3 are the population parameters. So the population mean is mu. The population proportion is p. Population standard deviation is sigma. Now these 2 are Greek letters. The population proportion is very often represented with pi, the symbol pi. So, if we could have called it pi, but I personally don't usually do that. So there is some kind of consistency here where the Greek letters are only going to be the population parameters. The sample mean is x bar, sample proportion is p hat, sample standard deviation is a lowercase s, and then these bottom 5 are just our general abbreviations here. Sample size is n. Degrees of freedom we're calling df. Chi-square is that scripty x squared. Significance level, alpha. Minimum verifiable difference, MVD. So I would know these pretty well. It will help. On the other hand, it will slow you down a pretty decent amount if you aren't familiar with these. But you'll always have your note sheet, so it's never an emergency. So now let's look at the 7 steps to hypothesis testing. We're going to talk about each of these steps individually. As a matter of fact, there is some extra practice that I'm not going to go over. It gives you a lot of practice for setting up this first step, which is the null and alternative hypotheses, your HO and your H1. So this first step is to read the problem, state your claim, set up your hypotheses, and then draw a picture using the correct distribution. So just like how with confidence intervals, proportions follow the z distribution, standard deviations followed a chi-square distribution, the mean, depending on what type of standard deviation you had, followed z or t. It's the same exact thing here, so you can take all of that knowledge with you in Unit 4. Second, perform an assumptions check. This is the same as we saw with confidence intervals. The assumptions are actually exactly the same. So that's not going to be very new at all. There's going to be more hypothesis tests and a few new assumptions. So that's the only new aspect up with that. It's still the same assumption checking that we have been doing. So next is find the test statistic, which is a new term to us, but it's not a new action. The test statistic is actually a z-score is what it could be, or it could be a t-score, chi-square score, and f-score. You're going to label them on your picture. You may have 1 or 2, and then shade your tails. So we're going to talk about tails in a few slides. The shaded tail always depends on your alternative hypothesis, which is your H1. We'll get to that. Find the p-value, which is the size of the tails that you've shaded in step 3. Make a decision about HO. Write a sentence regarding your claim. And then step 7, I usually put, and you'll see on all of my papers here, I'll put a line across because this is kind of a separate part of the problem. So they're going to go together, but you're not going to use the same picture. It's going to be a new picture down here. So find a confidence interval for your sample data. If you support HO, state how your confidence interval supports this decision. If you reject it, then you're going to find the same MVD that you found in Unit 3. So there are 3 overall major points to hypothesis testing. The first is that we are conducting a hypothesis test under the initial assumption that the null hypothesis, whatever that HO is true. So when we look at these problems, I'll emphasize that. I know a lot of this is going to seem kind of out there until we actually get to look at something specific. The second is that if sample data strongly suggests that HO is false, we reject HO. If the sample data does not suggest that HO is false, we fail to reject HO. So fail to reject sounds a really weird way to say that, but I'll explain that in a few slides. So let's start going through our 7 steps, which will be the remainder of this lecture. The first step is setting up your claim, your hypotheses, and your picture. So the first thing is to read the problem and to understand what is it that this group or that you want to test. So here are some samples for claims, and what we're going to do is rewrite them in mathematical statements. So you're always going to write your claim first. Some people skip this step. I don't recommend it. I'll always write my claim. So I would definitely recommend taking the time to go through everything as detailed as possible. The more organized that you are, the better that you'll probably have in hypothesis testing in general. So the first bullet, the true mean starting salary, which is another way of saying the population mean. So the true mean is the actual mean if we had every piece of information ever. For graduates of 4-year business school is $2,200 per month. So we need a symbol for the true mean, which would be mu. We're saying that it is $2,200, so that would be an equal sign. So the true mean starting salary for graduates of 4-year business school, mu is equal to 2,200. Notice that there's no unit in here. Units really will muddy this up and will make things more confusing. So you have complete permission to exclude a unit because this isn't information you're presenting. This is information that you're using yourself in order to set up a problem. The second bullet, the true standard deviation is at least 2.1 pounds. So sigma is the population standard deviation. And at least, this is where the language that we looked at in Unit 2 is going to come back into play. Because at least means that 2.1 is the smallest amount possible. So greater than or equal to is how we would represent at least. And then 2.1 with no unit. Lastly, the true proportion of juvenile offenders that are caught and sentenced to prison is less than 20%. So don't forget, percentages are just for show. We don't really want to use them inside of anything. So when you're considering this one, you're going to need to convert that percentage to a decimal. And the true proportion is going to be p, just lowercase p. Less than is just a less than symbol, and then 0.2. So this is always going to be your first step, is reading the problem and from that saying what you're looking to be testing, which is the claim. Once you have the claim, you want to set up your HO and your H1. In this case, the HO is called your null hypothesis. So null is another way of saying 0, basically. So this is H with the subscript 0. When you are formatting your assignments to turn into me, you do need to use the subscript for it. The alternative hypothesis is H1. Technically, your claim can be either HO or H1. However, in the real world, I would never have my claim be HO unless I absolutely had to. So, but it can be either one. HO is the null hypothesis, and it is a claim about a parameter, and we assume that this is true no matter what you're testing, no matter what you think is true, no matter what. This is the basis of hypothesis testing, is that HO, whatever this statement is a true statement. It always and only has an equal sign. This will cause problems. I just recommend being really careful when you set these up, because it's usually the people that are going the fastest that end up making little mistakes around this area. Lastly, H1 is the alternative hypothesis, and this is the competing claim. These two do not have to be opposites, but they cannot be true at the same time. So this is really important. This, I think, upsets people sometimes because HO will always have an equal sign, but H1 can have a greater than or less than or a not equal to. So it may not cover every single number possible at the same time, but they just can't be true at the same time. They can have absolutely no overlap. And then finally, the last piece of step 1 is your picture. Step 1 is actually one of your longer steps. You're going to spend more time on this because it's going to involve reading the problem and making sure that you understand what is asked of you. So I usually spend a decent amount of time on this first step. So the same that we found with Unit 3, with Unit 4, the picture that we draw depends on the parameter. So when we had a single mean, if the population standard deviation was known, that's Z. If we have a single mean and the population standard deviation is unknown, that's going to follow the T distribution. Single proportions follow a Z distribution. Standard deviations follow a chi-square distribution, and these are the order of the topics that we're going to be doing our hypothesis testing on. Two population means, both of their population standard deviations are going to be unknown, so there's going to be a T distribution. Two population proportions, Z. And then we've got this guy, pops out of nowhere. Two population standard deviations follows this F distribution. It's not really that bad at all. It's very, very similar to chi-square. We will talk about it when we get there in topic 8. And then lastly, we're going to look at the difference between, the difference between two population means is going to be the T distribution. I'm going to rephrase this before I put that back up. So step 2 is checking your assumptions. I'm not going to talk about it at this time because every test has its own set of assumptions that you are going to check. So this information is all going to be in your hypothesis test reference tables. So these are up in the topic 1 folder, and if they're not up already, I'll put them up in the reference tables folder. You're going to have those on your exams. So definitely make sure you know what's on that, because those are very, very helpful and really cuts down on the amount of memorization that you need to do, which in statistics, the goal isn't to memorize everything. The goal is to be able to think on your feet. Step 3, find the test statistics, label, and shade. So test statistic is basically how strong your evidence is. And the way that we're going to measure that is we're going to compare our sample data to whatever it is that we said that HO is. So if we said the mean is 10, that's maybe our HO, and our sample data shows that the mean is actually 22, well, I would probably say, I don't think your HO is looking pretty good here. So the test statistic tells you how strong your evidence is. This is also why HO can only have an equal sign, because we need a number, a specific number, to put in a z-score formula. So that's not the only reason, but it's one of the major pieces. We're going to be finding the test statistic by hand for the first test only, but every other test beyond this, we're going to be using Stata almost entirely for the rest of the course. The location of the test statistics is going to be the same exact way in Unit 4 as it was previously in Unit 3. So knowing these distributions will be helpful. I would definitely put that on your note sheet. And then again, deciding which tail is going to be shaded will always depend on the sign of H1. It actually has nothing to do with, where your Z or T score is. It's just based on what your H1 says. So you can't be a robot. I usually write on in step 1 which tail or tails I'm going to shade. So here are your 3 scenarios for H1. H1 can have a not equal to, it can have a less than, or it can have a greater than. So your picture will be two-tailed if you have a not equal to in your H1. So depending on what kind of distribution you have, you'll have one of these two things. The F distribution is almost this shape exactly. Every sample size has its own. So the F distribution is going to be one of these, this one as well. If H1 has a less than, the picture is left-tailed, which means, and I like this because it points towards the tail, but that means that we're going to shade our left tail. And if it is, oops, holy moly, we got these switched here. All right, so if it has a less than, it's left-tailed, and if it has a greater than, it's right-tailed. So the H1 is going to tell you which tail to shade. Sometimes people just shade the smaller piece. Like, so for example, if your Z-score was right here, but your test was left-tailed, some people will just shade the right because it's smaller. That's not always the case. You always need to look at your H1 to decide what to shade. Next, we have the p-value. So the p-value is the probability of getting a test statistic at least as unusual as what we've observed based on our sample data and assuming that HO is true. This is always going to be found by technology for us, except for the first one we are going to use the z-tables for. So this is kind of like the output of a hypothesis test. Step 5, make a conclusion about HO. HO, remember, we enter the problem assuming is true. So it's really important to come at the end and say, hey, we actually found that, HO is really, really super unlikely to be true, or we have no reason to refute that HO is true. So the analogy that is typically used for this is a courtroom analogy that accused are innocent until proven guilty. So HO is true until we find otherwise. And so our evidence in this case is our sample data. This also links directly to our 2 final decisions in a hypothesis test. If the p-value is less than the significance level alpha, which we then we reject HO and support H1. If the p-value is greater than the significance level alpha, we fail to reject HO. So if the p is low, reject HO. If the p is high, then null will fly, is a saying that people typically use. I'm actually just going to fix this because in this font, this looks like a regular A instead of an alpha. So those are our 2 decisions that we're going to make, and that's our first part of our decision. Because remember, at the beginning, we said your claim could be HO or it could be H1. So the second part, oops, we're still making a conclusion about HO. It's really important to set your alpha value in advance, and it's the same exact thing that we thought of with confidence intervals. It's also to understand, and this is really, really important, that we never prove HO is true. We just say there isn't enough evidence to reject it. This sounds really weird, but if you think of the courtroom analogy again, someone could be guilty, but there just might not be evidence at this time to prove it. So maybe the evidence is there, but it's it's like a body they can't find or something like that. So this is one reason why we don't want to set our claim as H1 if possible. So if you're in the real world and you're doing a hypothesis test, you would want to avoid making your claim be HO as possible, as much as possible. You can also think about this as how some cases are dismissed without prejudice, which means that if there isn't enough evidence at the time to proceed, they may allow the the case to be brought back. And that's kind of the same thing that happens with HO. So maybe we can't reject it at this time, but we'll get enough evidence, maybe future evidence says something a little bit different. But you have to remember, this all happens under the idea that if without statistics, we would have no information at all. So we still do have good scientifically calculated information in order to answer these questions. But we don't ever prove that HO is true. So that's one thing to remember. Step 6, make a decision about the claim. So your claim could be HO or H1. In step 5, you only make a decision about HO, so you need to make a 2-part decision. There's going to be a few bullets that are below. I recommend just thinking about it instead of looking at the bullets here. But if you reject HO, and HO is your claim, then you're also going to reject your claim. If you reject HO, but HO is not your claim, then you support your claim. So this is a very confusing way to look at this. But I wanted to officially put this into the PowerPoint because this is still true, but it's also, a very confusing way to think about it. It's better to just use what you've written out and have that as your guide. So I'll leave this up to you to read for the rest of the bullets. But in general, just think about your scenario and think about the conclusion you've made about HO and what that means for your claim. Finally, step 7. Step 7 is to create a confidence interval for your sample data. Confidence intervals are always going to go hand in hand with hypothesis testing. So when you find a confidence interval for your sample data, it should always support your decision about HO. So if you say HO is true and HO says that the mean is 10, well, 10 had better be in your confidence interval. One consideration that you do need to make is that alpha is the same alpha from your hypothesis test, but you may need to, you're going to need to draw a new picture, and the new picture has 2 different cases. So I'm going to leave these here for now because it's not very easy to understand this until we look at an exact problem, which is true of this whole entire lecture. It's very, very vague until we look at the specifics. But I recommend that everybody listen to this once, and then when we do topic 2, I would probably recommend coming back and listening to this again, because this is a pretty short week. It's going to typically be the exam week. So, I would listen through to this lecture and then just kind of leave it for here until you actually do a hypothesis test in topic 2. There will not be any assignments this week on this specific topic. However, there is a second video in which we will be practicing a few of these key pieces. So I would head over to the second video once you've given yourself a chance to rest.